Hi, so this video is going to be about differentiating with respect to x the function arcosh of 1 over x. So the inverse hyperbolic cos function of 1 over x. Obviously, the first thing to note is that we can't have x equal to 0, obviously because 1 over 0 is undefined. And before we differentiate this function, like what we've done with previous similar functions, let's just analyze the domain and range of this function, and we can do that by looking at the domain and range of this arcosh of x function without the 1 over x inside the function. So a graph of arcosh of x, so it looks something like this. So the inverse hyperbolic cos function looks something like that. You've got 1 there, so it touches the x-axis at 1, and as x tends to infinity, the graph actually tends off to infinity itself. And the reason why is because the arcosh function is the inverse of the cosh function. The cosh function, when we restrict the domain between 0 and infinity, kind of looks something like that, or probably more like this. So when you reflect the cosh function, so this red line is cosh. So when you reflect that in the line y equals x, you get the arcosh function. And obviously we restrict the domain because we don't want to get something like this, because cosh looks like that. If you would reflect it fully, you would get something like this. This is not a function because that's not a function. You can't have a many or a one-to-many mapping. That's not what a function is. A function is either a many-to-one mapping or a one-to-one mapping. And so, yeah, so the arcosh function is going to be that black line there. So we know that. So let's just make a note of the domain. So our domain is x greater than 1. Range, well, it's just the real well, any number bigger than 0, isn't it? So the range is well, between 0 and infinity. So then if we think about the arcosh of 1 over x function, which is what the whole point of this video is, differentiating that function. Let me just make this writing a little bit smaller. So yeah, when we think about the 1 over x function, sorry, the 1 over x inside the arcosh function, so with this one, well, we know the domain must correspond to the arcosh function up there. So the domain must be 1 over x greater than 1. But if 1 over x is greater than 1, well, that's just exactly the same as saying that x must be must be smaller than 1 or bigger than 0. So 1 over x has got to be a bigger number than 1. So 1 over x, this must be a positive number, has to be positive. So it means that the denominator has to be positive too, because the numerator is positive. So therefore, it means that x must be between 0 and 1, like so. Okay, so we know that. So that's our domain of the arcosh 1 over x function. And again, the range is just going to be the same as the arcosh function because the range doesn't change. So the range is still 0 to infinity. Okay, so we know that. And we can just bear this in mind when we differentiate this function. Okay, so we're going to differentiate the function. And it's going to be using the chain rule. So differentiating arcosh of x, 1 over x with respect to x. So we're differentiating a function of x. So this is going to be a chain rule problem. So we're going to differentiate with respect to 1 over x the function arcosh of 1 over x, and multiply that by the derivative just with respect to x of 1 over x. So again, this is just applying our chain rule, and we've done this in multiple examples in previous videos, so you can check this out if you're not too sure what we've done there. So again, this is just using the chain rule. Okay, yeah, so now we can differentiate these two results here. So if we think about differentiating the arcosh function, so again, we did this in a previous video. So the derivative of arcosh of just x. So when we differentiated this function, we got this result. So 1 over the square root of x squared minus 1. So yeah, that was the result that we got. So we don't want to differentiate a function of x with respect to x. We want to differentiate a function of 1 over x with respect to 1 over x. So we can just change the variables. So change this to a 1 over x and change this in here to a 1 over x, like so. And that means we're going to have to change this over there to 1 over x. So this becomes a 1 over x inside there. Okay, great. And again, we can just tidy this up. So we're going to get 1 over the square root of 1 over x squared, subtract 1 like that. Okay, great. So that's the first bit. So 1 over the square root of 1 over x squared, subtract 1. And then multiply this by the derivative of 1 over x. So we've done this in multiple previous videos. When you differentiate 1 over x with respect to x, you get negative 1 over x squared. And we could just multiply out the fraction. So top times top, we get minus 1. Bottom times bottom, we get x squared multiplied by the square root. So the square root of 1 over x squared minus 1, like so. Okay, then, so what we now know is that when we differentiate the arcosh of x function, sorry, the arcosh of 1 over x function, let's say, we get negative 1, sorry, not negative 1, yes, negative 1, my bad, negative 1 over x squared times the square root of 1 over x squared minus 1. We can just factor out a 1 over x squared from inside that square root on the bottom. So we get 1 over x squared multiplied by, so x squared, sorry, not x squared, sorry, 1 minus x squared, like so. And then if we just tidy this up a little bit, so we get negative 1 over x squared from there. And we can divide this by this square root of 1 over x squared there. Well, multiply it by the square root of 1 over x squared, which is just the same as dividing it by root x squared. And then multiply that by the square root of 1 minus x squared, like that. Okay, so we get that result there. Again, I'm just going to make the writing a little bit smaller. Okay, and now then, well, we know for a fact that the modulus of x is defined as the square root of x squared. So that we know that this down here, well, that's just going to be negative 1 over x squared over the modulus of x multiplied by 1 minus x squared. And we also know that when you do x squared divided by the modulus of x, well, that's just the modulus of x there. And so therefore, again, what we can say is the following. So negative 1 over the modulus of x multiplied by the square root of 1 minus x squared is our result. So we can say that. So we know that when we differentiate arcosh of 1 over x, we get negative 1 over the result that we got, which was modulus of x times by 1 minus x squared inside a square root. So that's the result really for this video. However, what you will actually notice if you saw the previous video is that when we differentiated the function r-sech of x, we got exactly the same result. So we got negative 1 over the modulus of x multiplied by the square root of 1 minus x squared. So we got exactly the same thing with this. So the natural question becomes, is this arcosh of 1 over x function the same as this r-sech function? So is arcosh of 1 over x equal to r-sech of x for all x values in their domains? I mean, if they're the same function, then they're going to have the same domain anyway. So I'll just write domains with a plural. Okay, so what we can do then, we can actually check and compare their domains. So if we think about this arcosh of 1 over x function, well, we know that the domain is x between 0 and 1. So let's look at the rsech function, and that domain. So we actually did this in the previous video. We sketched the graph y equals rsech of x, and this graph looks something like so. So between 0 and 1, and something kind of like this. Sorry, not like that. I should not draw the line by the y-axis. Something that tends to infinity as x tends to 0. So something kind of like that. So yeah, as we can see here, we've got a domain. So a domain of 0 to 1, and that domain is exactly the same as the domain of the arcosh of 1 over x function. So yeah, they've got the same domains. So therefore, domain of rsech of x equals domain of arcosh of 1 over x. And because they've got the same domains and they've got the same derivatives, then they must be the same up to a constant. So therefore, we know that arcosh of 1 over x equals rsech of x, but up to a constant, so plus c. So we want to, or we could determine what that constant is. In fact, that constant is actually going to be 0, so they're actually literally just the same function. But let's prove that, and we can do this by just letting y be equal to rsech of x. So therefore, what that means is that sech of y must be equal to x, because rsech and sech are inverse functions. We know by definition what sech is. So sech by definition is just 1 over cosh, literally just by definition. And we can just rearrange this to write cosh of y equals 1 over x. So now we could apply the arcosh function to both sides. So arcosh of cosh of y equals arcosh of 1 over x. So you may be thinking, okay, well, surely this left-hand side there just goes to 1 because arcosh and cosh are inverse functions. So actually it does, but we can't just be immediately so bold and just assume that. And that's because this y there is not a variable. This y is a function. So we've got a function of a function of a function. So we've just got to be careful to check whether we do get y on the left-hand side there. And to do this, we've got to check what the range of y is and compare that to the domain of this cosh. If cosh's domain is the same or contains the range of y values, then we're okay. This will work. So let's just check that. So the range of y equals rsech of x. So the range of y values, well, if we go back to our rsech graph, so the range was from 0 up to infinity, isn't it? So we got a range from 0 up to infinity. So that's our range. Let's just write that there, 0 to infinity. Now let's check the domain of the cosh function. Well, the domain of the cosh function is exactly the same as the range of the arcosh function, because cosh and arcosh are inverse functions, and the domain of a function is the same as the range of this inverse function. So therefore, if we just check the range of the arcosh of x function, Well, we've already sketched this graph back here, and we can see that the range of the arcosh function is 0 to infinity as well. So the arcosh function has a range 0 to infinity. So the range of the r-sech function is indeed contained by the domain of this cosh function, which means that the arcosh and the cosh will just cancel out to give us the y function. So we're okay. So the arcosh function range is the same as the r-sech function range, and so we don't have to worry about leaving it as it is. We can just cancel out the cosh and the arcosh. Okay, so that's all good. So let's just actually make a note of this down here. So therefore, arcosh of cosh of y equals to y, and this obviously equals to the right hand side of the equation, which was arcosh of 1 over x. And indeed, y equals arcosh of 1 over x, and y equals r-sech of x, and so therefore those functions are the same. So r-sech of x equals to r-cosh of 1 over x for all x values in the domain. And we know that the domain for the functions is the same, so it's 0 to 1. So for all x in 0 to 1. And yeah, so that means then that obviously they're going to have the same derivatives, and the derivatives are, well, that derivative there, so that function that we derived in this video, which is the same as the function we derived in the previous video. So yeah, that is that video finished.